Greetings class, this is your instructor James, and I wanted to make a quick video on some of the key introductory content in Chapter 10 titled Nutrients Involved in Body Defenses, which will give us a nice overview before our class time meeting. Primarily in this chapter we're going to be talking about substances known as antioxidants, and you've probably heard of that term before, antioxidants. I want you to think for a moment, what provides antioxidants? What provides antioxidants? There's been a lot of heavy and aggressive marketing of antioxidants. And so when you think what provides antioxidants, your mind might immediately go to some of those products that you find on a supermarket shelf that claim to be high in antioxidants. And there's a number of those anywhere through the supermarket aisles, as well as many, many antioxidant supplements that companies will pitch and promote to consumers. A couple years back, there was even an antioxidant soda product that came out, which to me was incredulous that a company would try to fool and deceive consumers into believing their cola would be a good source of antioxidants. And so because of this marketing, and some of it again is deceptive, we can lose sight of what foods in our diet are actually rich sources of antioxidants. And that's really where our focus will be in our class, and also something I want you to think about within not only your own diet, but also with your volunteers' diet in the service learning project. It's not about your volunteer going to the supermarket and spending money on these food products, many of them which are processed that have antioxidants added to them, which aren't already naturally occurring, but rather identifying some antioxidant-rich foods that they can start adding to their diet. And you can tell from these pictures, mainly those are plant-based foods. There are a couple antioxidants that you find in animal products, but the overwhelmingly abundant antioxidants are going to be found in plant-based foods. So what do the terms antioxidant and associated term free radical mean? So let's start there. Atoms typically contain an even number of paired electrons, and that's when they are stable within our body. What makes them unstable is when they lose or gain an electron. And that's what turns them into this term that we call free radical. Free radicals are substances within the body that can move around and damage other parts of the cell. Antioxidants will ultimately defend against those free radicals. Now, one of the most common free radicals in the human body is actually a form of oxygen. So even though we've been taught all of our lives that we can't live without oxygen, it's a vital substance, and that is true, oxygen undergoes reactions that actually turns it into a very harmful free radical. And so we can't live without oxygen, obviously, but we have to protect ourselves when oxygen undergoes reactions that turn it into a free radical. Now, oxygen is not the only free radical that exists in our environment or in our body. In fact, free radicals are formed and produced by many, many different ways and means. So pollution that's in the air is a very common source of free radicals that humans are exposed to. Something else when you go outdoors and you're in sunlight, right? Which we know that here in Colorado, we're 5,000 feet closer to the sun, so we're exposed to more UV light as well as more radiation in the atmosphere. So you could argue that here in Colorado, we're getting exposed to a higher level of free radicals than people who are living at sea level. And we know that UV light can cause free radical damage both acutely and long term. right? Here in the spring months when the sun is starting to shine, the weather's nicer, we go outdoors, we forget to wear sunscreen because we're just coming off of the winter months. We go outside for a long time on a weekend day, we end up with a sunburn. So that would be an acute form of free radical damage. If we don't learn our lesson and we continue to do that again and again and again, we know that that long-term exposure to UV light is going to hasten the formation of aging spots, wrinkles, and ultimately could cause skin cancer, which would be considered long-term damage from free radicals. There are many toxins that we may potentially introduce knowingly. For example, smoking is a major source of free radicals and is partially believed to be why smoking causes cancer. Excuse me. But smoking obviously is not the only toxin that we come into contact with. Most chemicals that we use, whether it's something like paint or a cleaning substance, things of that nature, pesticides that we might use, or just other chemicals around our home are a potential source of free radicals as well. And it's not just, again, related to these harmful chemicals in our environment, but reactions, again, involving oxygen that convert oxygen, this life-giving substance, to a harmful free radical. So if you think about this, when you exercise, you actually upregulate those reactions with oxygen because you're breathing more, right? And so that actually can be a potential source of free radicals as well. And then when you have a fast metabolic rate, which may help you to stay lean or stay at your desired body weight, that means you have more reactions with oxygen, more potential for free radical formation. So the picture I've painted here is that it's basically free radicals are everywhere. And it doesn't matter really who you are, you're going to get exposed to free radicals. Now, why do we care about this free radical formation? Well, it's well documented in the scientific community that free radicals can cause damage to our cell membranes, which basically destroys the integrity of our cells. It can damage low-density lipoprotein, which we learned about in Chapter 5. When it does so, it makes them more likely to stick to the arteries of your heart, which can cause a heart attack. The proteins that are in our cell, if you remember, there's tens of thousands of protein. If they become damaged by free radicals, they no longer function the way that they should. And then lastly, free radical damage to our DNA can cause mutations which lead to cancer. Cumulatively, we refer to this massive amount of free radical damage as oxidative stress. And it not only accelerates the aging process, but also heightens the likelihood of some type of disease. And so there are many diseases, chronic diseases, that can be linked back to free radical damage. Again, the top killers of Americans are shown on this list, but also not necessarily chronic diseases per se, but also conditions that afflict our older and possibly even our younger population, things like arthritis, which can make it difficult to be mobile, as well as our vision in the form of cataracts. So that's a lot of the bad news. The good news is that we can defend against this free radical buildup. And we have two ways that we can do that. The first way is an innate system or endogenous system, something that's within our body, or what I call homemade enzyme system that detoxifies these free radicals. In other words, it converts them into a harmless compound. The most common harmless compound they can be converted into is simply water. Now, this innate endogenous enzyme system, again, they are built up or made up of enzymes in our body that are made, lots of them made by the liver. However, they require the presence of certain dietary minerals, the major one being selenium, along with, as you see here, manganese, zinc, copper, and iron. And obviously those minerals come from our diet. So in class, we will identify the food sources of many of these minerals, which are important to support the enzyme system that detoxifies free radicals. And here's a nice illustration of a few reactions involving these enzymes where they, as you can see here, we have copper, zinc, manganese, these enzymes that take a harmful free radical and convert it into, by the presence of these enzymes, into the harmless compound of water. The other way that we can defend against free radical damage is via the antioxidant nutrients, which we would consume directly from food, and what they do to nullify the damage of free radicals. If we remember, a free radical is a substance with an unpaired electron. So these antioxidant nutrients will actually themselves donate an electron to that free radical, which essentially renders it harmless. So it's a different type of action, but it achieves the same ultimate benefit. And so there are many, many substances that are referred to as antioxidants: vitamins, vitamin precursors, and phytochemicals. The classic antioxidant nutrients are beta-carotene, which is a vitamin precursor to vitamin A, vitamin C, which we've talked about many times already this semester, and lastly, vitamin E. But we'll explore some other compounds that are referred to as antioxidants as well, outside of these three. So again, as this video closes up, free radicals are those harmful substances that can move about the body, damage cells, damage proteins, damage DNA. The antioxidants can work to help defend against those damaging effects of free radical and hopefully prevent the early onset of disease and maybe slow down the process of aging. And this is another nice illustration that shows a cell and the various different types of antioxidants that work within the cell, both in the cell membrane, which we know that is made largely of lipid. So we would expect to see vitamin E, a fat-soluble vitamin, and beta-carotene, also fat-soluble, operating that domain. And then within the cell, we have also other sources or sites where free radical damage can occur. Inside of the cell, we have it's mostly water-based, the cytosol, right? Or cytoplasm, and that's where we see a lot of the water-soluble nutrients exerting their protective effects. Okay, well, this gives us a nice overview, and I hope you enjoyed this video, and I'll see you on class.